In this video, we're going to look at solving equations with fractions by clearing the fractions to create whole numbers to make things easier to solve. So the first step you want to do in this type of problem is find the lowest common multiple of all the denominators. So here we have a 5. This could really be thought of as 3 over 1. And then here we have a 5. So the 5, 1, and 5, the lowest common multiple of those three numbers is 5. So if we multiply everything on both sides by 5, what will happen is we'll create whole numbers to make the equation much easier to solve. Okay. Remember though, what you do to one side, you have to do to the entire side on the other side of the equal sign. So here, if I multiply by 5 on the right side, not only do I have to multiply by 5 here, but I also have to multiply by 5 with the 3 as well. And that's one of the biggest mistakes I see in trying to solve by this method is not multiplying everything on both sides by the number you've selected. Okay? So we're going to distribute the 5 to the k over 5, and we're going to distribute the 5 to the 3. Well, 5 times k over 5 is really 5 over 1 times k over 5. Multiply across. 5 times k is 5k. 1 times 5 is 5. And 5 divided by 5 just becomes k or 1k. So 5 times k over 5 becomes just k. So I'm going to erase this right here. And underneath the k over 5, I'm going to put a k to represent the distribution we just carried out. So of course you can rewind it if you want to see what I just erased. So this became k. Now we also have to multiply it by the 3 as well. 5 times 3 is 15. And then lastly over here, 5 times 8 over 5. Well, that's really 5 over 1 times 8 over 5. And 5 times 8 is 40. 1 times 5 is 5. And 40 divided by 5 is 8. Or, if you're getting quicker at this, you could have cross-canceled. So, you could have seen diagonally here that 5 goes into 5 one time. So what you would get was 1 times 8 is 8. 1 times 1 is 1. Which also equals 8. So whichever method you prefer, this one's a little shorter, but you have to recognize the shortcut. Okay? So this now becomes 8. So what you can see happened by multiplying by the lowest common multiple on both sides, which again is a legal move because we did the exact same thing to both sides, so we kept everything in balance, is we got k plus 15 equals 8. So that is a much easier equation to solve than the one above it with the fractions. So now all you have to do is subtract 15 from both sides. And 8 minus 15 is a negative 7, so k equals negative 7. So let's look at one more example. This time we'll look at one with two different denominators. Okay, so let me pull the question up. So what we have is z over 5 equals z over 8 plus 5. Okay? Right. So what we want to do is look for the lowest common multiple of 5, 8, and this 5 is really over 1, but the 1's not going to come into play. So it's really 5 and 8. So to find that lowest common multiple, this is going back to the beginning of the semester. We could do the ladder method. Look for a prime number that goes into both 5 and 8. And I'm not seeing one. 5 is prime, so the only number that's going to go into 5 is 5, and 5 does not also go into 8. So this is the end of our ladder, so that means we multiply the two numbers that we started with. And our lowest common multiple is 40. So I'm going to write LCM equals 40. Okay. So, just like we did in the previous problem, we're going to multiply the entire left side by 40 and the entire right side by 40. So not just the fractional parts, but the entire side on both sides. So that's also going to include, in this particular case, this whole number of 5. Okay? So 40 times z over 5 is really 40 over 1 times z over 5, which is 40z over 5 when we multiply numerator and numerator, and then denominator and denominator. And 40 over 5 is 8, so this really equals 8z when we begin to clear the fractions. All right? So this was kind of the longer method of writing it out. I'm going to cross-cancel here to look at the shortcut way to do it for the 40 times z over 8. So for 40 times z over 8, look diagonally to see what's going to go into 8 and 40. The largest number is 8. 8 goes into 8 once. 8 goes into 40 5 times. So 5 times z is 5z, and 1 times 1 is 1. So that equals 5z. And then don't forget 40 times 5 as well is plus 200. Okay? So again, we've taken both sides and multiplied them by the lowest common multiple of the denominators, And what that did was clear all the denominators to create an equation with only whole numbers, which is much easier to solve. Okay? So we want to get the z's on one side and the numbers on the other side. So I'm going to subtract 5z from both sides. This cancels, 5z minus z cancels, and 8z minus 5z is 3z equals 200. All right, finally 3 times z equals 200, so to finish this off, to undo multiplication, we divide both sides by 3. 3 divided by 3 cancels, and you are left with z equals 200 over 3, which is a correct form of the answer, but it's not the most simplified form. Sometimes MathXL will take that, sometimes it won't. If it needs to be changed, we would carry out the division to change it to a mixed number. So what that would be is you want to ask yourself, how many times does 3 go into 200? And it's going to go in a total of 66 times with a remainder of 2. So the answer is 66 2/3 for z. So depending on how the program wants it, it could accept 200 over 3, but technically an even simpler form would be 66 2/3. So that is solving equations with fractions by clearing the fractions to create only whole numbers. Okay? And again, the way we did that was to identify the lowest common multiple of the denominators in the problem, and then multiply the entire left side and the entire right side by that lowest common multiple to generate only whole numbers, and then solve from there. Okay? So that concludes this video.